Hey guys, I'm Teddy from Arcane Rituals. Welcome to our second devlog for our in-development semi-traditional roguelike. It's been a couple of weeks since the last devlog and things have come on quite a bit. We've made progress both in terms of the game's design and the implementation of our ideas. I've finished most of the very basic mechanics you need to make a roguelike, and I've made them generic enough that we can use them for multiple different entities, with the option of extending the logic wherever we need to. One of the areas we've made a lot of progress in the last 2 weeks is the overall design of the game. In early discussions we were leaning towards a more traditional roguelike, but since then we've scratched out enough interesting setting ideas and game mechanics to create something more akin to a narrative roguelike. The basic gameplay loop will be doing runs in the game to collect resources that you can then use to create equipment, complete jobs, upgrade your base, etc., which will introduce modifiers into the game and possibly buff your character a little bit. We're trying to be as conscious as possible of the inverted difficulty curve that many roguelites have, whereby the game is hardest at the start and progressively gets easier as you gain power-ups and better gear. We're probably going to ultimately create a system whereby you can't complete a run all the way through to the end without upgrades and better gear, but we are going to try and offset this by having the narrative affect the runs in interesting ways. We want the meta mechanics and the story to be as interesting to the experience as the actual roguelike part is. Anyway, onto the tech part. The first thing I implemented after basic movement and level generation was an algorithm that determines what the player is able to see. We wanted our system to start with our levels completely obscured to the player, with tiles in their line of sight become invisible the first time they see them. The system then reveals the hidden tile, but greys it out if the player isn't in a position to see it. You can see this working in the video just now. Instead of doing tile counting logic to figure out what is and isn't visible, I'm just looking at the specific tiles in an arbitrary sized box around the player and then doing a basic line cast to see if anything's in the way. All the entities in the game have got a component called collision data that lets us set variables that determine whether an entity is passable and see-through, etc. This works really well in that it's really easy to set up, and it can be extended to incorporate any number of things we add to the game, and it's also relatively efficient. I think we can run the algorithm hundreds of times per frame, so that's decent. After I had that working, I added basic mobs to the game. At this point, the mobs are still just green blobs with a health bar. If you're in a cardinal direction from a mob at the end of your turn, the mob will attack you. In turn, you can bump attack them, just like in most traditional roguelikes. However, one of the most important aspects of our combat system is going to be spacing. We want melee combat to be extremely deadly so that the player almost never engages with it on purpose. At most, 2 to 4 bumps from a trash mob will kill you. The aim of the game here is spacing. Cleverly funneling enemies, laying traps, and dispatching them in the most beneficial order are going to be the main combat interactions in this game. All the skills we'll be adding for the 4 planned characters will aim to facilitate this. There's also going to be much more mobs on screen at once in this game compared to traditional roguelikes. Managing your spacing is going to be a tactical challenge, and picking equipment and skills to create interesting synergies that let you do it should keep the game interesting. Since melee combat is so dangerous, we're going to be relying heavily on ranged combat, and that's where our game's going to stand out the most, I think. In this current build, pressing left control will bring up an aiming aid, which you can then use to fire a shot. Firing a shot also ends your turn, so generally it's beneficial to kill enemies that are closest to you first. You control the direction of the shot manually, so you don't have to be in a direct line from the enemy you're shooting at. You can see here that Poncho, our character, has got a 6-shooter, and that the game also tracks ammunition. Poncho can reload his gun, but he can only reload 1 bullet at a time, and loading a bullet into the gun also passes the turn. This means that if you run out of ammo in a fight, the gap between you and the mobs will close as you reload. Right now there's a difficulty cutoff in that the game becomes impossible at a certain point as you can't really do anything about getting surrounded. However, once we start adding skills, this is probably going to change. There's going to be positional skills, combat skills, item skills, melee skills, etc. All of this is going to coalesce to create a system where a clever player can fend off an almost arbitrary number of mobs if they are smart enough. Speaking of skills, I've created a basic system for them. There is a base class that represents a skill whose inherited overridden methods control what it does. In a run, we want the player to only have 4 skills available, which will be chosen from a larger set as they level up. So creating a genetic system means we can control all this in a really abstract and simple way. The skill we've implemented to demonstrate this allows the player to ricochet a bullet. You can see that in action just now. This was actually a total bollock before, as we were using the built-in 2D physics system to do the bounces. However, that caused a ton of irritating problems, so what I'm doing now is I'm doing a line cast from the player to the first target, and then a line cast from that target to the next, and so on and so forth for the number of bounces. We then use these vectors to move the bullet along the given path. This looks a lot like physics, but it's actually much cheaper computationally, and it gives us much finer control over our projectiles, which is exactly what we want. Just now, anything that has a collider can cause a ricochet, so walls, trees, rocks, items, enemies, etc. Before I did most of the combat stuff, I also implemented pathfinding into the game. This is the thing so far that I'm least happy about. I've got it working semi-efficiently in that I can calculate a path for a given mob very quickly, but it's still not efficient enough to sort of boop the frame rate in certain scenarios. I'm using Unity's dot system so I can do the calculations using structs instead of classes, but the act of creating a struct representation of the game board every time paths need to be calculated is kinda shite. Shit like this often happens when you're prototyping stuff because the code you write is designed to be thrown together very quickly, and since I'm still learning, it's written the way Unity developers find most optimal. So we're going to have to take another look at this game board and the underlying architecture so that there's always a struct representation of the game board available for the pathfinding to use. Once we've got that, I'm relatively sure we can calculate a path for a given unit in less than 1/10 of a millisecond, especially if we split the board into chunks. Anyway, that's it for this week. If you want to keep up to date on the project, then subscribe to our channel. We are only 1 million subscribers away from quitting our day job. We've also got a Discord linked in the description, so if you'd like to hang out with us and even affect the development of the game, you should join that. We're probably going to be distributing prototypes really soon, and I'm always keen to speak to players and other devs about ideas. Ciao for now.